In this example, we would like to show you some of the diagnosis options available for the exhaust gas recirculation system using the MegaMax 66 diagnostic tool. After preparing the vehicle appropriately, you start by connecting the diagnostic tester to the vehicle. Once the vehicle registration data are input and the desired function and module are selected, the diagnosis may begin. Always start by reading out the fault memory. The fault memory indicates that a malfunction has occurred in the exhaust gas recirculation system. You also receive additional information that's helpful for the next steps. Here, the information indicates a defective exhaust gas recirculation valve, or EGR valve. In this case, you can change to the Actuator Test functional scope of the diagnostic tool to check the actuation of the EGR valve. To do so, you select the appropriate component and start the actuator test. Because of ambient noise in the repair shop, we advise you to touch the component so you can detect its actuation by the engine control unit. Another diagnosis option is to read out the system parameters. Change to the Parameters functional scope and then select the measured value ranges required for the EGR valve. Now, start the engine. Exhaust gas recirculation is not active while the engine is idling. The EGR valve is passive at this time. The EGR valve becomes active when the engine speed exceeds 2000 revolutions per minute and various engine parameters are met. In this case, the test shows when the EGR valve is actuated. The next step is to monitor the measurement module and the measuring technique functional scope to check the voltage supplied to the EGR valve. In this context, always take the vehicle manufacturer's specifications into consideration. You start by using the test probe of the measurement module to measure the voltage supplied to the EGR valve from the relay. Apply the black terminal to the engine mass and unplug the connector to the EGR and insert the red positive test probe into plug connection E. Switch on the ignition and read off the measured value in the diagnostic tool. In this case, the voltage supplied to the solenoid coil reached the specified values. Next, check the voltage supplied to the position sensor by inserting the red test probe into plug-in contact D. After switching on the ignition, it becomes visible that the supplied voltage is within the specified range here as well. To check the ground connection of the EGR valve, connect the red test probe to the positive battery and the black test probe to plug-in contact A in the connector housing. This also reveals no fault. The EGR is removed for the rest of the tests. Now, perform an electrical check to determine the resistance values of the EGR valve based on the vehicle manufacturer's specifications. The resistance must be measured in turns between contact pins A and E, B and D, and B and C at room temperature using an ohm meter. This is followed by a functional check of the solenoid coil. For this check, connect the solenoid coil to a voltage supply with 12 to 13.5 volts. Connect contact pin E to the positive battery. Contact pin A is now connected to ground at short intervals via a cable. This actuates the solenoid coil on the ground side and checks the function of the valve stud. The valve must operate audibly and should open trouble-free. In this case, heavy contamination has blocked the stud axis, thus causing the EGR valve to fail. By comparison, see that the EGR valve stud correctly actuates and returns to its starting position based on the voltage supply. Once the new EGR valve is installed in the vehicle and the event memory is cleared, a test drive with a connected diagnostic tool should be performed to verify that the system is functioning properly.